Hello, everyone, and good evening, sir. Welcome to iTalk series on IoT, Internet of Things. And today we have Mr. Saket Kumar with us, presently working as Head Innovation and IPR in Amity Innovation and Design Center, Amity School of Engineering and Technology, Amity University Uttar Pradesh, Noida, UP, India, graded by NAAC and ranked 32 in NIRF from August 2017 to till date. Additionally, he has more than 9 years of teaching experience at UG and PG level in various engineering institutes and universities. So, today, let's start this session, and I would like to hand over to Mr. Saket Kumar.
Yeah, thank you, Anmol Agarwal.
Yes, sir.
So I'm sharing. How many audience we have right now? Am I audible?
Yes, sir. So, we have quite a few of them.
Okay. Okay. Are they joining here or they are online? They are joining from
Sir,
YouTube.
from YouTube, sir.
Okay, from YouTube. Fine. So it means I don't know I don't know about the audience. So let me start the basic introduction of the Arduino.
Yes, sir.
It's a pre-defined lecture which I have right now. So the session is the 5 day workshop is related to the Arduino, right? So in the first lecture, I will take only few minutes to introduce the theory part of this board, and then after I will go to with the practical session, right? So most of the time we will go with the hands-on practice. So I would like to request everyone, if you have Arduino board and a few sensors, then you may start the interfacing with this board. And also, if you can purchase, if you do not have this board, then you may purchase this board, right? I think my screen is visible, Palak.
Yes, sir.
Sorry, Palak. Yeah. So, if you do not have the Arduino board, then you may purchase it in today or tomorrow, so that even tomorrow, so that you will be able to uh, join the interfacing hands-on practice with me, so that it will be more familiar to you, right? The Because it's a hands-on practice course, it's not a theoretical course, as I informed by the management. So that will be better if you will get the Arduino board, right? So first, the introduction of the Arduino is an open source electronic platform, and if you will see, it has a very big community, right? So very easily you may download the Arduino Ide software, okay? And this device is a programmable device, so you may upload multiple programs or multiple times a program. Even if you can, if you want to change a single word in the program, then you may change it, and then you can program it again. In the previous microprocessors, what we need to do, that if we are uploading any program, any hex file in the processor, then again it need a burner, right? Without a burner, we cannot upload any program in the processor. Then, after uploading the program, we need to unplug the processor from the board, and then it will be, and then it will work. So this is a common fundamental of this processor. But after that, we have this Arduino board. Just a minute. After that, we have this Arduino board, and it doesn't need any any burner to upload the program, right? It has a it has inbuilt burner, inbuilt bootloader, so it will upload the program automatically multiple times. So in this board we have microprocessor, right? RAM, program memory, AD converter, oscillator, everything. It's a complete package of a processor in which you can upload the program multiple times. I hope you know about these things: microprocessor, RAM, right? It's random access memory, then program memory, then AD converter, analog to digital converter. Okay, so this is called as a development board, right? Here you can see the highlighted part. This is the power supply, 3.3 volt regulator, because this board is able to provide 3.3 volt to the sensor. Also, if the sensor is operated on 5 volt, then it has 5 volt supply, right? It's Arduino Uno. So let me show you few boards which I have right now. So these are the Arduino boards. You may see it. Just wait. So these are the boards on which we will work, right, in these 5 days. These are the sensors. So I'm just removing the sensor from here. So we have lots of boards right now. So one by one, if I will show you, the first board is Arduino Mega. It's the biggest board in Arduino family, right? It's called Arduino Mega. Arduino Mega, the advantage of this board is it has 53, 54 digital pins, right? 16 analog pins. So you may connect 16 analog sensor and you may connect 54 digital sensors with this board. It means if you are making a sensor box where all the sensors are connected with one board, then you may use this Arduino Mega. The size of the board is very big, right? So according to it, the PCB will design and it will easily mount on the PCB like this, right? Am I audible and visible?
Yes, sir.
Okay, just wait, my camera is stop working. Uh, am I audible?
Yes, sir. You are audible.
Fine. So now you can see the screen. I think the boards are visible right now. So this is Arduino Mega, right? And After that, we have Arduino Uno, which is a little bit smaller than Mega. You can see the size of Uno is just half of the Mega, right? But it has only 14 digital pin, right? Where we have 0 and 1 is RX and TX pin. So normally we ignore this pin. And now we have next board, and we have 7 analog pins in this particular board. So you can see we have 7 analog pins and 3.3 volt and 5 volt power supply also there. So this is our second board. Now we have this another board that is called as Arduino Nano. Normally we use this board in the uh, projects, right? Because of the size. This particular board and Nano is a replica of each other, right? This Nano board has 16 digital pins. You can see, 14 digital pins and 7 analog pins. Similar like Arduino Uno, 7 analog pins and uh, 14 digital pins, right? So you can see the size of this board. If you can put it like this, then it's very smaller than the Nano. Then what is the difference between these two boards? The difference is of output current, right? Few sensors need higher current, so we cannot interface those sensors with Nano. We need to use Arduino Uno for that. So we can use Nano with most of the sensors, right? It reduces the size of the PCB also. When you will use it, then it will reduce the size of the PCB, right? So we have these 3 Arduino boards, right, which we can use in our projects: Mega, Uno, and Nano. Now, apart of these boards, we have another few boards you can see here, which we will cover in fourth or fifth day of the workshop, right? These are called as Node MCU. Okay, these particular boards has ESP8266 modules. You can see this. This is ESP8266, which support Wi-Fi. So you need, if you want to upload the sensor data to the server, then you need these boards, right? Because Arduino Mega, Uno, and Nano has not the facility to upload the sensor data to the server. It cannot connect with the Wi-Fi. Okay, so you know you need Node MCU for that purpose. So I will recommend first purchase Arduino Uno with the data cable. This is the data cable of Arduino Uno, right? So you need to purchase this, and then you can also buy this particular Node MCU. It will use in your project. When you will make the project, then it will be useful. So advantage of this board is it can be connected with the Wi-Fi, and disadvantage of this board is it has only 1 analog pin. So you can connect only 1 analog sensor with this board. But after that analog pin, we have 14 digital pins in this board. So you can connect 14 digital sensors. Now we can come to the sensor. This is an ultrasonic sensor. So it can be connected with the digital pins, right? And the sensor DST11, DST22, temperature and humidity sensor, it can also be connected with the digital pins. So these two sensors can easily connected with this Node MCU, and it can upload the data to the server through the Wi-Fi, right? After this, we have another category of the board. This is called as bolt, right? You can see this is called as bolt. So it can connect the digital sensors, right, and analog sensors also, right? But it will work as digitally, and it has also ESP8266 module on the board, so it can be connected with the Wi-Fi also. right? So you can see one, two, three, four. Only four digital pins are there, and only one analog pins are there. You can see. So this board is only used to upload the data of four sensor, four digital sensor, and one analog sensor to the server. So it's a small board, smaller version of this Node MCU, right? The manufacturer is different. So these are the different Arduino boards which we have right now. Let's come to the lecture. So now we will see another different boards which is available for the Arduino, right? So in Arduino we normally use Atmel or Atmega microprocessors, right? So this is Atmega 328 which is used in Arduino Uno. So if you will see, this is Arduino Uno processor. We can unplug this processor. Even in Mega you cannot remove the processor, right? In Uno you cannot remove the processor, but in Nano, but in Uno you can remove this processor and you can use this processor in your board, in your PCB. So you can use also you can use Uno as a burner also, right? As a program uploader. Then you can remove this particular IC from here and you can use in your PCB without these setups. Okay. Now, if we see the programming console of Arduino board, then we have three parts of Arduino. First is physical hardware, the second is programming console, and the third is community, right? If you are facing any issue in any program, in any interfacing, then you can post your problem in the community and they will help you, right? So many developers are there who are sitting just to help to others, right? To run this community. Now, we have different types of Arduino boards. Uno, Leonardo, we will see one by one. Leonardo 101 Robot, right? ESP-LORA. It's support robotic and the different data uploading also. Then we have Micro and Nano, right? Now, every board is different from the others, right? In terms of ampere, in terms of voltage, in terms of analog, digital pins, right? Every board is completely different. So now you can see we have Arduino Uno. We already see the Arduino Uno. Now you can see the specification of Arduino Uno. PWM pin, which is very important for the PWM generation, right? Pulse width modulation signal it will generate. So if you want to control the speed of the servo, then you can use this PWM signal. If you want to control the angle of the servo, then you can use this PWM signal, right? Then we have analog pins and we have digital pins. Okay, 14 digital pins, in which we have six PWM pins, PWM output. So we can take PWM output from this uh, Uno. Now you can see the ampere. It gives 20 milliampere when you are using IO pins, right? And if you are taking current from 3.3 volt, then it will give 50 milliampere. Now different boards have different memories, right? So flash memory is 32 KB. You can also save few parameters, few values in the Arduino Uno RAM. You can use the RAM also of this Arduino Uno, and also you can use the ROM, read-only memory of this processor. So we have EEPROM, SRAM of 2 KB, EEPROM of 1 KB, right? And now we have this clock speed, everything is there. And also we have this width and weight, right, for this Uno. Now if you will see the Arduino Leonardo, then it's little bit different than Uno. It has 7 PWM pin and 20 digital pins, right? So you can purchase Leonardo also for more digital pins. The current IO pins 40 ampere and 50 milliampere. So you can see here we have 20 milliampere, here we have 40 milliampere, right? The flash memory size is same. SRAM we have 2 KB, here we have 2.5 KB, but EEPROM is same, right? So slightly different than Uno. Then we have Arduino 101. You can see 14 digital pins, 4 PWM pins only, and then 6 analog pins. But you can see the flash memory. We have 32 KB. Here we have 196 KB flash memory. So you can store more. And then SRAM is 24 KB. Here you can see the SRAM is 2.5 KB only, right? So this is slightly different than the other two. Then we have Arduino Robot. It's a very big board which you can easily make robots in this board, right? You can mount these things and you can make the robot, right? Because it has so many pins, and also you can see. Let me show you the diagram. The diagram look like this. It has an LCD, speaker, LEDs, control pad, right? Processor, reset button, compass. Then if you will see the another part of the Arduino robot, then you will get IR sensor activity display LED, right? Then wheels. Everything is embedded in this board. You doesn't need to purchase anything because it has wheels also. So you need to just assemble this robot and you can program it. Okay. Then we have Arduino ESP LORA. So here we have different controls on this board. It's like a video game because it has a joystick also and the controls. So it will work as a remote and as a controller also. So you can also use this Arduino board for the flight controller. So you can see we have four switches here, LDR sensor, right? Then buzzer, joystick, different controls are there. Also, we have temperature sensor, potentiometer, RGB, LEDs, accelerometer, right? So everything is there in this board, which normally we interface these sensors with the Arduino board and we make a complete system. But on this board, we have all the parts. Now, micro is the smallest board of Arduino family. Even Arduino Nano is bigger than Micro, and also we have Arduino Mini, right? So Arduino Mini is the smallest board. So you can see we have the USB port here to upload the program in this micro board, and you can also see the specifications. The specifications is approximately same like Nano, right? We have 20 digital pins and 7 PWM pins. It is the mapped version of Arduino 101, and Arduino Nano is the mapped version of Arduino Uno, right? Now this is the smallest board of Arduino family, Arduino Mini. But this board has not the USB port, so you cannot even micro USB or mini USB. So you cannot connect this board directly with the computer, and you cannot upload the program directly from the computer, right? You need Uno to upload the program on this board. The size of this Arduino Mini is uh, smaller than Nano. You can see the length 30 and 18 mm. 30 means 3 centimeter, only 3 centimeter. The length of this board is 3 centimeter only. So if you have a scale, then you can see the length of this board. And 18 means 1.8 centimeter only. So you can also use this board because in the smaller in to miniaturize the project, and you can see we have 40 milliampere DC IO current and 14 digital pins, 8 analog pins. So you can use this board when you will miniaturize your project. Then we have Arduino Mega. We already seen this board. So Palak, do we have the option to ask questions or by the students? I think we have not the options, right?
Can you repeat, sir?
So if students may ask the question, then it will be better. So do we have provision for
Yes, sir.
this?
Yes, sir. They can ask questions on YouTube, and then we can show that comments to our live stream.
Okay, okay, fine. So now we have this board, right? Now we will see the Arduino IDE. Now let's see the Arduino IDE part. Uh, that was the introduction of Arduino board, and now we will go to the software through which we can upload the program in these boards. Okay, so let's just start the new program. Then I will introduce you everything. So this is Arduino software, Arduino IDE, right? Here we have these controls. Through with this button, we can verify the program is correct or not. From this button, we can upload the program to the controller. We have new page also options. We can open the new program page. Then we can open a existing program and we can save the program which we are writing here. Now we have different things here. You can see file. In file we have new open and open recent and then sketchbook and then example, different examples here, right? Close, save, page setup, print, preference. We will go one by one here. So first we will see the preferences. So in the preferences, you can see we have a settings for the sketchbook location. So you can change the location where you want to save your all programs, right? So it will change the location of your Arduino while installing. Then you can use the editor language, right? Whatever language you want. So you can use system default, that is English. Then you can use the font size. You can increase the font size, like I'm using 22 right now, so it will be visible to you. Then interface scale, that is automatic. Theme, we have different settings here for the Arduino. Then we have show verbose output during compilation and upload. So whenever we will check these two buttons, two checkbox, then it will show that the program is compiling and the compilation file is uploading somewhere. It means it is saving in the memory of the system, and where it is saving, it will show the path of that directory. So it doesn't need to search the directory in your system. You can directly take the path from the compiler, right? I will show you how. Then this particular display will show the line number. You can see the line number here. Then verify code after upload. Check for update on startup. Right, these are the settings. This is the important setting for us. We already told you about the Node MCU ESP8266 module, right? So ESP8266 module is not available in the Arduino software. So if you want these boards in the Arduino IDE, then you need to upload this path here in the preferences. These two paths, we will go with this, and then it will be shown in the board manager, right? And then you may upload your program. to the node MCU. So this is for the additional board manager URL. So this URL will provided by the manufacturer of the board, and then it will upload the board to the ID, right? Then in the file section after preferences we have examples. Whatever the library, whenever you will upload the library in the Arduino IDE, then it will create an example page, and you can access the example, right? Like basic, you can access Blink program, right? Blink program is for the LED blinking. I hope everybody is know about the LED blinking. So it's a very simple program which is already available in the Arduino IDE. If you are new in Arduino, then you may upload this program to the board, right? And it will show you LEDs, right? Let me show you on the camera. I'm facing some issue actually in the camera. Okay. Okay. So you may see it. The LED is blinking right now. Okay. And if we just wait, yeah. Okay. So right now the LED is glowing. Both the LEDs, the line and the TXRX LED is glowing because it is transmitting the sensor data to the Arduino IDE, right? Now, how to upload this particular program to the board? If you are new in the Arduino, then it is very important to understand the procedure that how to upload. First, you need to choose a board, right? So here in the tool option, you can see the board option, and through the board manager, Arduino AVR board, you can choose the board, the correct board from the list. So when you will choose the board, Arduino Uno, then you need to choose the port of the board. So first you will choose the board and then you will choose the port. Port is COM4. Okay. And then after selecting this board, you are ready to upload the program in the board. So first you can see the picture of the board. Both the lights are glowing. Now I am using inbuilt LED. Inbuilt LED of this board, built-in LED, right, which is already connected with the 13 number pin. 13 means this particular digital pins, right? So if you will upload this program through this button, First, it will compile the sketch, right? And it will verify the sketch. If any error will be there, then it will show in this black screen compiler, right? And it will have, if it is completely okay, then it will go through the upload process. So right now you can see the uploading process. Now I told you about the preferences page, why we check these two options, right? If you will check these two options, then you will get a path of hex file. You can see the path of hex file, right? And if you will get this hex file path, then you can find the hex file, and you can use this hex file in any controller, right? For this blinking purpose. Now you may see the LED which is blinking right now on this board. Okay, right now it is blinking with the speed of 1 second. Okay, if you want to change the time of this blinking process, then you may change it through this delay. Like I'm putting it for 5 seconds, then it will be turned on for the 5 seconds. So, what is the meaning of this delay? This delay stop the previous execution of the program in the controller. So, you can see the blinking process has been changed for this delay. So this is the initial program of Arduino IDE. So you can access it with the examples, basic programs, right? You can access it with the examples, basic program. Digital, you can use buttons and other things here, right? Then we have analog, communication, then control, then sensors. So we have so many examples here and how it appear here. When you will upload any library, then it will shown here, right? So you will get the example of everything. Then we have edit. In the edit, normally in the software, every software we have different options in the edit for the editor box, right? So you can increase the font, decrease the font size, right? Then we have a sketch. This is important. Sketch means this is called as a sketch. The window of Arduino is called as a sketch. So you can verify the program from here. You can upload the program. You can upload the program using any programmer if you want programmer. So in the tools we have programmer also, right? Suppose particular Arduino board or any other board need different programmer to upload the program, then we have different programmers here, right? Arduino ISP is the default programmer when you will install your uh, Arduino ID. So we have upload using programmer folder. If you will click here, then it will go to the sketch folder, right? Here you can see the text and the Arduino file, right? Then we have include library option, right? Here you can import library of different sensors. Like if I will click on manage library, then it will open a window where you can import different libraries, right? Right now it is updating the library folder which we have already installed, right? It is updating the list of the folder. Now, if suppose I am using a fingerprint sensor, so I will just write here fingerprint sensor. So you can see we have fingerprint sensor library, right? And GT5X library, which is already installed. Fingerprint library. Because, sorry, I have this GT5X fingerprint sensor. That's why I installed this library. If you have normal fingerprint sensor, then you can use this uh, library, right? Then we have R30X fingerprint sensor. So according to the device which you have, you can install the library, right? Like if I'm writing here temperature, then it will show us the library related to the temperature, right? Now I'm writing here temperature sensor, then it will show the library related to the temperature sensor, right? So you can install the library from here. The second option, you can download the zip folder from GitHub or from the other browser. So if you will open, then if you need a particular sensor, like if you need sensor for the LCD display, right? So you can just write here library for GLCD, that is graphical LCD. So you can get the library for the graphical LCD on the GitHub, and you may download it, right? But if you will download, then how to import this library? You can download the zip file. Now, if you will get this zip file, you doesn't need to extract this zip file, right? You can directly import this zip file in the Arduino. How? From the sketch include library, you can add zip library here. So you can click here and go to the download. GLCD master. Here you can see it. Just wait. Okay. So we already download this zip folder, and now you can open this zip folder here, and you will get a message. You can see library added to your libraries, right? Check include library menu. So you can check the library menu, and we have the GLCD option here. You can see the GLCD master library is here, right? Now, if you imported the library, then it will show the example of the library also. So you can access the example through file examples, and then you can go to the GLCD, right? So yeah, now you can see the example of the GLCD. The first introductory program is there, right? So you can access any program. So if you will import any library in the software, then you can access the library in the include option and in the example option, right? So okay. Now if we will go to the tools, then it's auto formatting. If you will select it, click auto formatting, then it will format it. What I am telling, what is auto formatting? Let's see it and see. It's auto formatted program, right? The alignment of the lines, it will be auto formatted. Now you can archive the sketch. We have different options: serial monitor and serial plotter. These are very important: serial monitor and serial plotter. If you are connecting so many sensors with the Arduino board and you are not connecting any LCD, right? And you just want to see the output of the sensor, then you need to use this serial monitor, right? It doesn't need any display, any LCD display or any type of display, right? You can see the output on this serial monitor. How? Let's see the example of this Arduino board. We have this board right now. Okay. I'm facing so many problems. Okay. So we have this board right now. So we can connect anything with this board, and then I will show you how to use serial monitor, right? So we can also see the output on this serial monitor, right? How? First, we need to enable the serial monitor from the setup file. So you can activate the serial monitor through this setup file. So the command is serial dot begin. Then we need to give a baud rate, which is the communication rate between the system and the hardware. So through this command, it will activate the serial monitor, right? Now we can give the message here serial dot print ln. Serial dot print ln. We have a set of commands for the serial monitor. We will discuss it in the later on slides. So here you can write any message. Right? If LED is turned on, then you can write LED is turn on. Right? And then after this, we can use the same command. LED is off. Simple. So when you will upload this program, you can see the timing of this LED. Here I'm reducing the timing 2 seconds and 1 second. And uploading the program to the controller. Right. Now you can see the message here. You doesn't need to see the message on LCD. If it is appearing here, then definitely it will appear on the LCD, right? And you know the loop function is a infinite function, so it is executing the lines, right, and then going to the loop function again for the infinite time of the loop, right? So you can see the message LED is turned on, LED is off. So this way you can see the output of the sensor on the serial monitor, right? So if you have serial monitor, then you cannot open the plotter. Plotter is for the plotting the graph of the sensor, right? Okay. Now we can see the two serial monitor, serial plotter, right? And then it is a firmware updater. You can also take the board information. If board is connected with the software, then you can see the Arduino Uno board. Right. Some time you will not get the port information here. Right. It will not show the port information. To rectify this problem, you can go to the device manager of your system. I'm just showing the rebooting, troubleshooting of the port problem. Few students will get the problem in the port, like port is not detecting or the Arduino software is not detecting, Arduino software is not detecting the Arduino board. Then what you need to do? Just go to the device manager. When you will connect, you will get this type of symbol, right? In the ports. In the port, you will get this type of symbol. So if you will get this type of symbol, you can simply update the driver. And if you're not getting the updation, then you can go to the properties, or you can go to the update and you can choose the driver, respective driver. And if you do not have this driver, then you can download the driver from the Google, and then it will be automatically detected the port, right? So this is the troubleshooting if you will get problem in the port, right? Okay, so this is all the Arduino software, right? And one thing what we are missing. No, I cover everything in the Arduino software, right? So if you know the simple C++ program, then you can write the program here. Okay. And now let's go to the next one, next section, the interfacing section, right? So simple, we have this particular LED. I told you this LED is connected with the 13 number pin. You can see the 13 number pin. It is connected with the 13 number pin. And how we will get it? I'm connecting an LED with the 13 number pin and ground. You will get lots of tutorial on YouTube for this. You can see the LED is glowing right now with the same rhythm of the onboard LED. So I told you it is connected through the 13 number pin, right? If you want to connect it with the another pin, then you can connect it. I'm connecting it with the 10 number pin. I connected it with the 11 number pin, right? So how can we define this pin? I'm taking a new program here. Process to define the pin in the Arduino board. We have two ways to define the pin. First, you can define the integer LED and equals to 11 number. It means LED is connected to the 11 number. But the better way to define the pin is has defined an LED and 11 number, right? So it means your LED is connected to the 11 number pin. Now, in the setup, you can define the port of the LED. With what will be the behavior of the port? It will be output or input. So for this purpose, we use pin mode, right? For the pin mode, LED is a variable. You can also take it L1 or L2. It's a variable, right? So here we have LED, and then you will define it as a output port. So we have two types of port in the controller. Either it will be output or it will be input, right? So it defined here. It is an output type. Then you can define it like if it is a digital pin, then you will write here digital write, right? Digital write LED high. High means 1 and low means 0. I'm giving delay of 1 second, and then again I'm writing here digital write LED low, okay? And then delay 1000, 1 second again. So this way you can connect your LED with the Arduino board. You need to save the program and you need to upload the program again. And you can see the blinking of the LED with 11 number pin, right? No, my LED is not good. Again stops. Okay. Again, the camera has been stopped working. So you can see the blinking of the LED, right? On 11 number pin. So this is an introductory lecture for this Arduino, right? And the first interfacing is LED. Now this is an ultrasonic sensor, right? This is an ultrasonic sensor. So you can connect this ultrasonic sensor with this board. You can see the ultrasonic sensor has 4 pins, right? And what is the working of this? The one sensor, this one sensor generate a sound wave, ultrasonic sound wave, right? In the ultrasonic frequencies. And then this sound wave collide with the object, right? And then come back and it will receive with this particular sensor. When the sound come back and it receive with the sensor, it then generate a echo voltage, right? When it trigger, then it generate a echo voltage, and Arduino read that echo voltage, right? And then it will show the distance of the object, right? So from 1 centimeter to 30 centimeter, this sensor works perfectly for the 30 centimeter. So if you want to detect the obstacle between 1 centimeter to 30 centimeter, then you may connect this particular sensor, right? So guys, do we have any question, Palak and Anmol, or not?
No, sir, not yet.
Okay, fine. So let me show you the example of this Arduino board. How can we do this? How which type of things we can perform with this board, right? I'm showing an example to you so that you will be impressed, or you can create your own product in your home, right? Just for the fun and for other things also. So let me show you an example of this interfacing. Then we will go with that interfacing also, right? Okay, give me a second. So guys, I'm showing you a minion, right? Dancing minion, which I just programmed for 5 or 6 modes, right? Just for the fun purpose, we can interface this type of toy also, so that it is not compulsory that if you learn anything, then it will be work for the professional purpose only. But you can also make this type of attractive things so that so so are you able to see this minion? So you can see the walking of this minion. Is it visible, everyone? Palak, is it visible?
Yes, sir. Yes, sir.
Okay. So you can see it's a 3D printed model, right? But everything inside the minion is servo and Arduino board, Arduino Nano, right? So you can see the modes of this dancing, the backward and forward motion. It's all from the servo, and we have the ultrasonic sensor also. So it will continuously change the uh, motion. You can see it. Now, if we go inside this minion, uh, then you can see we have Arduino boards, right? We have Arduino boards and the servo motor. Through the servo motor, we can control the motion of this minion, and we can program the motion, right? You can see everything is inside the minion. So this type of things you can create if you will learn the interfacing of this board, right? So how we can interface different sensor. First you see the LED. Now I'm connecting this ultrasonic sensor with this Arduino board, right? So for this, I will take a breadboard. You can see the breadboard here. In the breadboard, you already know that these lines are sorted vertically and these lines are sorted horizontally. So I will use this sensor in four different lines. Right? We have eco pin. We have eco and VCC pins, right? So it will connect to the eco and VCC pin. So first I will connect eco pin, right, with the Arduino Uno. Then I will connect VCC with 5 volt, right? And then we have two pins here. One is eco and the other is trigger. So I am connecting the eco pin. Then I will show you. Let me connect first. So you can see I connected this particular sensor with the Arduino Uno, right? And now I can write the program for this sensor, right? And then I will show you how to measure distance, how this sensor measure distance, and then I will also connect this sensor with Node MCU in the later on lecture, and I will upload the data to the cloud. So let me write the program for this ultrasonic sensor, and then you can see it will show the exact distance. You can also measure with the scale. I have a pre-write program for ultrasonic sensor. Name as distance sensor. So I connected the LEDs with this LED, right? So I also connected I can connect the LED, but I'm not connecting the LED here. Mm, just let me open the different examples. Mm, Okay, I'm not getting the correct program here. I think it should be there, but okay, no problem. Yes. So we have two right now. So let's write the new. Okay, I'm deleting the second one. Fine. Okay, let's write the new program. So if you want to interface this ultrasonic sensor, then you need two pins. The first is trigger pin and the second is echo pin. So first you will define trigger pin, which is already connected. You can see in the picture, it is connected with 10 number pin, right? So I'm writing here 10. Then you need to define echo, right? Which is connected to 9 number pin. Okay. So if you will see, trigger pin and echo pin is connected to 9 and 10, right? And we doesn't need anything uh, for this, but we need to set up something in the file, in the setup file, right? First you need to set up serial begin, serial dot begin, which is 9600 baud rate, right? And then you will define the pin mode, trigger, comma, output, and pin mode, echo, comma, input. I told you trigger pin generates the ultrasonic sound, and then after a collision, it come back to the sensor, and then echo pin generate a voltage, and which will be act as an input to the Arduino board, right? So you can see it. Now we need to apply some formula. Which type of formula? The formula of sound. So the sound is going to the object and it is colliding with the object and coming back. So the speed of the sound. So if we want distance, then distance equals to speed upon time, right? So we need to implement this formula, but we need to take the values from the first. We need to generate the trigger, and so if you want to generate the trigger, let me copy and paste to save the time. So if you want to generate the trigger, then first you need to generate the trigger, and then you will use delay microseconds. It means for 2 microseconds only you will add the sound. So for 2 microseconds it will generate uh, ultrasonic sound, right? And then you need to receive it. So we will see the pulsing function when we will go to the lecture, slide lecture, right? So if you will get this, then after generating this for the 2 microseconds, right, uh, you need to first you need to generate the ultrasonic sound, then you need to convert it into the low portion again, right? So you can just write here digital write, okay, and then again trigger. First you need to set it for the low, and then you will generate this trigger, and then delay in microsecond again. 10 microseconds you will generate it, and then again it will set to the low position. It means it will generate a trigger pulse for few microseconds, and it will show to the low. It will set to the low, right? When it will go to the low, then it will receive a echo from through the another sensor. For echo, we have a function here that is called as pulse in function, right? So whenever we will use pulse in to the Arduino board, then that particular pin wait for the pulse coming to that pin. It means it will wait for the higher impulse. So whenever it will receive the pulse uh, from anywhere, then it will make a higher potential on that pin, and that higher potential will be read by the Arduino board, and that is for that particular higher potential, the Arduino board will hold the pin, and that is called as pulse in, right? So you can take it as float duration equals to duration means the time pulse in, right? So here you can see echo pin. So for the echo pin, we are getting echo pin higher, right? And it will uh, calculate the time, time in microseconds, just for how many times, for how much time the echo pin is high, right? And then you can simply use this formula, distance by 2, duration divide by 2. So what is the meaning of this duration divide by 2? It means one, the sound is generating from the sensor. It is going to the object and then it is coming back. So it traveled the 2 times distance, right? That's why we are dividing it by 2. So it is dividing by the 2. Now, if I will show you this on serial monitor, distance, right? Then you can see the also adding some text in the serial monitor, serial.println. Distance h, this one, right? And uploading the program. Okay, so the program has been uploaded here. You must see. Okay, we need to use delay, otherwise we cannot observe the output. Now you can see this is the output of the proximity sensor. Now, what is this? See, I'm using an obstacle in front of ultrasonic sensor, and you can see the time, which is 137, and it is increasing. It is increasing with the because I'm going far with the from the proximity sensor. You can see this is the object in front of proximity sensor, and you can see the output is 90 right now. I'm going far from the proximity sensor. You can see the distance right now, which is increasing. Okay, so what is this actually? What is the which type of value is this? This is not the distance, right? This is not a distance. This is just the time in microseconds, which it is taking and it is receiving from here, right? This is not the sorry for the this is not a distance, right? Distance in centimeter. This is a time. For this particular time, this time is taking by the sound to come back to the sensor, right? This time is in microseconds. Now, if you have a time and if you have a speed of the sound, then you may easily find the distance of the object, right? So through this, we can find the distance of the object. So this is all the proximity sensor interfacing, and we will go level by level in the next few lectures, right? And then after and the fifth day we will upload this data to the server also. So Palak, can we stop here for the today? If
Yes, sir, sure. No problem.
right. So because all the setup is set up in my home, and right now I'm in the office. So from tomorrow we will start with the new setup, right? So thank you guys for today, and tomorrow we will start again for the 2 hour session completely. Today I am taking only 1.5, 1.3 hours, right? Only 1.5 hours. Okay, Palak and Anmol, can we stop here?
Yes, sir, sure. Thank you so much, sir.
Okay, any question we have right now?
No, sir.
Okay, okay, then thank you for today, and tomorrow we will start from here.
Thank you, sir.
Thank you.